Hello everyone, this is lesson 74. In this lesson we are going to talk about the connection between confidence intervals and significance tests. So I have mentioned in class how highly related these three units have been. So Unit 5, Unit 6, and Unit 7 are very highly connected to each other. Unit 6 and 7, confidence intervals and significance tests, are based off of the idea of sampling distributions. And even further, for confidence intervals and significance tests, one of the biggest similarities is that the conditions that we check are the same. So in this lesson, we are going to get a little bit more specific about the connection between a confidence interval and a significance test and what one can tell us about the other. So in today's lesson, we are going to talk about how a confidence interval could help us determine the result or the conclusion of a significance test. So a confidence interval can tell us if we reject or fail to reject. I'm going to say that one more time. A confidence interval can tell us whether we would reject or fail to reject a null hypothesis. It also works the other way around. So given a hypothesis test with a p-value, our test can tell us if a value for mu or p is in the confidence interval. So a test can tell us if our value, the null value for the parameter, is in the confidence interval. So I'm going to say those two things one more time. What we're looking at today is how confidence intervals and significance tests are related. One of those relations is that a confidence interval can tell us the conclusion to a test, so whether we reject or fail to reject, and a significance test can tell us if the null value will be in a confidence interval or not in a confidence interval. So let's look at some concrete examples of what I'm talking about. This relationship only applies to two-sided tests. So for two-sided tests. For two-sided tests, your confidence level will be equal to 1 minus alpha. So what does that mean? That means that a significance test at the default of 5% will give the same result as a 95% confidence interval, because 95 and 5 equal 100. So for a two-sided test, there is a relationship between your significance test and your confidence interval. Whatever alpha is, if you subtract that from 1, that'll tell you what your confidence level is. So before we go through and look at some specific examples, just going to highlight that this is for two-sided tests. And if you look at these alternative hypotheses in the first two examples, they're both two-sided. So the first relationship, I think, is the easier relationship and the more interesting relationship. So we want to test a null that mu is 1.5 against an alternative that it's different than 1.5. So we're testing that the true average is 1.5 against that it's different than 1.5. A 95% confidence interval for mu is 1.4 to 3.6. Based on this, would we reject the null or fail to reject the null? So the first thing that I want to pull is my alpha level. Based off of this confidence, our alpha is going to be the default 5%. Our alpha is 5%. And if you feel more comfortable writing it as a percent, you can do that. You can literally write 5%. So how does this help us decide if we're going to reject or fail to reject? What we're looking for is whether or not 1.5 is in this interval. So we're checking to see if the value from the hypotheses is in the interval. So at alpha is equal to 0.5, we would fail to reject the null. Why would we fail to reject the null? Because the value of 1.5 is in the interval. The value of 1.5 is in the interval. So we fail to reject because 1.5 is in the confidence interval. So that tells us that 1.5 is a plausible value for mu. We would fail to reject because it is in the interval. Fail to reject because it is in the interval. Okay, next one. We want to test the hypotheses that mu is 6 against the two-sided alternative that it's not 6. What we're looking at is whether or not it's in the interval. So in this case, 6 is not in the interval. What will our alpha level be? Well, this time we're looking at a 99% confidence interval, which means that our alpha would be 1%, because they're complements of each other. So up here, 95 and 5 add to 100, 99 and 1 add to 100. So at alpha is 1%. We would reject the null. Why? Because 6 is not in the, oh, we already have the word "the" written for us, confidence interval. So it is not a plausible value for mu. So this confidence interval tells us that 6 is not a plausible value, so we conclude the alternative. We conclude that our true mean is not 6. So I'm going to grab a Post-it and I'm going to write down, I'm going to sum this up, write it down on a Post-it note, what we have discovered here. So if mu sub 0, so if the mu from the null is in the interval, So I'm going to say mu sub 0 is in the confidence interval. Then we fail to reject. So the takeaway from this top part is, if the null value is in the confidence interval, then we fail to reject. Conversely, if mu sub 0 is not in the confidence interval, then we reject the null. So what we've learned from these top two examples is that we can determine the result of a hypothesis test by looking to see if the value given in the hypotheses is in the interval. If it's in there, fail to reject. If it's not in there, reject. Okay, the other part of this is slightly more involved. So for determining whether or not a value will be in a confidence interval, we look at our p-value. So for example 3, they tell us that the p-value for a two-sided test of the null hypotheses that mu is 10 is 6%. So that's said a little bit weird, but what essentially they're telling us is that p-value is 6%, and our alternative, you don't have to write this, but the alternative is that mu is not 10. It's different from 10. How do I know that? Because they tell me here it's a two-sided test. Does the 95% confidence interval for mu include 10? So does the 95% confidence interval for mu include 10? So first things first, let's identify that our alpha is 5%. And now we're going to compare our p-value. So since the p-value of 6% is greater than our alpha of 5%, we fail to reject the null, or fail to reject HO. So they give us our p-value, they give us our confidence level. We compare that p-value to the alpha given by the confidence level. So if we fail to reject, that means 10 is in the interval. If we fail to reject, 10 is a plausible value. So we write the 95% confidence interval will contain you could also use the word include. I'm going to write that, /include 10. So 10 is a plausible value for mu. We fail to reject, which means that we do not have evidence against the null. We do not have evidence against the fact that mu is 10. So if we don't have evidence that it's not 10, that means it will be in our confidence interval. 10 is a plausible value for mu. What would we conclude if we changed the confidence interval or confidence level to 90%? Well, that means our alpha now is bigger, twice as big, it's 10%. Since the p-value, so same p-value above, 0.06, is less than alpha of 10%, we reject the null. If we reject the null, that means we conclude the alternative. We conclude, I wrote HO there. That's HA. My apologies. That's HA. So we conclude that mu is not 10. We conclude mu is not 10 because we reject the null. The 90% confidence interval will not contain or include, whichever word you prefer, 10. So it is not a plausible value for mu. Okay, now that we've gone through example 3, I want you to try example 4. So I want you to pause the video. I'm going to have to pause the video in order to fill this out, and then let's check in and really give it a try, please. Okay, pause. Okay, I realized as I was working through my problem a better way to explain this portion. So for the first one, the first confidence interval, does the 99% confidence interval include? Well, that should say 15. Because mu, the null is that mu is 15. So these were both typos. I'm sorry if that messed you up. Since the p-value 3% is greater than 1%, we fail to reject the null. The 99% confidence interval will include 15. Why? Because we don't have evidence against mu is 15. So if we don't have evidence against mu is 15, that must mean that 15 is a plausible mu. It is a plausible value for mu. And if it's plausible, it must be in the confidence interval. So up here where I said the 95% confidence interval will contain 10, so it is, I shouldn't be saying so it is. What I should be saying there is because 10 is a plausible value for mu. And then down here, it will not contain 10 because it is not a plausible value for mu. So carrying on that idea, for a 95% confidence interval, that will make our p-value less than alpha is 5%. So we reject the null. we have convincing evidence that mu is not 15. That means that our 95% confidence interval will not include 15 because it's not a plausible value for mu. We've already decided to conclude the alternative. We've decided to conclude that mu is not 15. And if mu is not 15, then it will not be in the interval. So our takeaway from this portion is the following, and I'm going to put it on another Post-it. If your p-value is less than alpha, so p-value is low, reject the null, or reject the hoe. Well, what does that mean if we reject? Reject then means that it's not in the confidence interval. If the p-value is greater than alpha, we fail to reject, which means that our value will be in the confidence interval. So we have two converse, inverse, opposite, I don't really know what the right word is, but we have two different things we're looking at. I think it's inverse, and they're inverses of each other. So in the top portion, what we have discovered is that based on whether or not our mu is in the confidence interval, we can decide whether we fail to reject or reject the null. So that was the first part. They give us the confidence interval, and we use that to decide if we reject or fail to reject. The more complicated one is comparing the p-value to alpha and knowing what conclusion we would make. So, knowing that if we reject the null, it's not in the confidence interval. If we fail to reject the null, it will be in the confidence interval. There's a few practice problems after this, so I want you to give those a try. Now, this is one of those units where if you're sitting there after you try the check for understanding, thinking, what has just happened? How are we figuring this out? I cannot keep track of all this. Then this is one part of this unit that you could let go. It's better to have in your toolbox. It is better for you to understand the link between a confidence interval and a significance test. However, if I had to pick and choose the thing that I was going to spend my time on to study for the final exam, it probably would not be this. So use that for what you will. I'm hoping that you feel okay about this. You will have time in class to ask questions, and if you're a distance learner, send me any questions that you have. I think that's it. Love you. See you in the next one.